Hi friends, in this video we are going to discuss about previous gate questions in our DC missions. Let's see here. Figure shows the extended view of a two-pole DC machine with 10 armature conductors. Extended view of two-pole DC machine with 10 armature conductors. Normal brush position A and B actually. Normal brush position actually A and B. Placed at the interpolar axis. So let's see. I am drawing here. For example, this is our DC machine. For example, this is our DC machine. North pole and south pole. And here the brush position A and B at interpolar axis. If the brushes are now shifted in the direction of rotation, for example, my rotor is rotating in this direction, they given already. In the question they given, my rotor is rotating in this direction like that. So, for example, my rotor is rotating in this direction. Now, brushes shifted in the direction. Now, brushes are now shifted in the direction of rotation. Brushes shifted in the direction of rotation. Nothing but, for example, like this. Now, this is the brush position A dash, and this is the brush position B dash in the direction of rotation, and A dash and B dash as shown in figure. A dash and B dash, these are A dash and B dash. The voltage waveform E voltage across A dash and B dash will resembles. How the voltage waveform will be at this condition, at this instant of time. At this instant of time, how the waveform induces. So generally, the flux will flows from north pole to south pole actually. This is the flux waveform actually in the machine. But whereas the conductors are simply the brushes are shifted in the direction like this, then actually the armature flux is produces in this direction. The armature flux is produces in this direction. This is generally the armature flux direction. And this is the main field flux direction, and this is the armature flux direction. Due to this, the magnetization and demagnetizations will take place. Due to this magnetization and demagnetizations, the waveform induced in the armature conductor is due to magnetization and demagnetization. Like this, the induced voltage or induced EMF should be like this. The magnetization effect and demagnetization. This is the at magnetization pole tip. This is at demagnetization pole tip. And this is at magnetization pole tip. This is at demagnetization pole tip. Like that. Here, they given in the option 0.2 pi, 0.4 pi, 0.6 pi, like that waveforms also they given. So the answer is, this is the correct answer. We have to choose the waveform like this. Due to magnetization and demagnetization, the EMF waveform will be like this. This is simply about the question here they given. Yes sir, next question. This is also linked answer question. In that, this is the first question and I will give you next question. So let's see here. A separately excited DC motor runs at 1500 RPM under no load. 1500 RPM under no load. 1500 RPM. With 200 volts applied voltage to the armature. They given the no load speed 1500 RPM and applied voltage 200 volts. Field is maintained at rated volt. There is no change in field excitation. Nothing but the flux is same. And next one, the speed of the motor, when it is delivers a torque of 5 Newton meters. When the torque of 5 Newton meters, the speed they given 1400 RPM. At 5 Newton meters of torque, the speed they given 1400 RPM. 1400 RPM as shown in figure. The rotational losses and armature reactions are neglected. Rotational losses neglected and armature reaction neglected. Then the armature resistance of the motor is, we have to find out the armature resistance, RA. Let's see here, at no load, nothing but Ia is equals to 0. Nothing but EB naught, no load. That's why EB naught is equals to V minus Ia RA, where this value is 0. If this value is 0, total value is 0. So EB naught is equals to 200 volts because supply voltage is 200. This is EB naught. And this is N naught. Now, the EB divided by EB naught is equals to N divided by N naught. Yes or no? Separately excited, right? For separately excited machine, EB2 by EB1 is equals to N2 by N1 because flux is constant. That's why EB2 by EB1 is equals to N2 by N1. EB2 by EB1 equals to N2 by N1. Then find out EB. EB is equals to EB naught into N. What is N? 1400 divided by 1500. Then you can get 186.67 volts. Then you can get 186.67 volts. This is EB value I get. I get EB value. Then I have to find out armature resistance, right? How we can find out the armature resistance now? Let's see here. Next, let's see here. EB is equals to V minus IARA. Actually, EB is equals to V minus IARA. But here they given torque also and speed also. Torque is there, speed is there. From that, we know that P is equals to omega into T. P is nothing but EB into IA is equals to 2 pi N by 60 into T. If you substitute here, EB value 186.67 and IA is there is equals to 2 pi 1400 by 60 into 5 Newton meters. If you solve this equation, then you can get IA. This IA is equals to 3.925 amperes. IA is equals to 3.925 amperes. IA value, you can get IA value from this equation. IA is equals to 3.925 amperes. Yeah, you got IA. Next, tell me now, EB is equals to V minus IARA, where EB is the 186.67, V is the 200 volts minus IA. IA is the 3.925 into RA. 3.925 into RA. If you solve this, then you can get armature resistance. If you solve this, then you can get the armature resistance of 3.39 ohms. Then you can get the armature resistance of 3.39 ohms. Yeah. What is the procedure here? This is separately excited. That's why EB2 by EB1 is equals to N2 by N1. EB2 by EB1 is equals to N2 by N1. For that, I calculated EB naught at no load. At no load, IA is equals to 0, so this value 0, EB naught is equals to V. Then after torque and speed, from that speed is there, EB is there, EB we have to find out. I find this 186.67. Then after P is equals to omega T, EB into IA is equals to 2 pi n by 60 into T. From that, I calculated IA value. From that, I calculated RA value. 3.39 ohms for this question. For this question, the answer is 3.39 ohms. This is the first question. For the motor, deliver a torque of 2.5 Newton meters. The torque of 2.5 Newton meters at 1400 RPM. The speed is same, but torque reduced to 2.5 amperes in second question. The motor delivers a torque of 2.5 Newton meters at 1400 RPM. The armature voltage to be applied is, actually, here EB is equals to V minus IARA, and EB at 1400, 86.67, 186.67 we just calculated, is equals to V we have to find out, minus IA also we have to find out, because this is another IA. Don't substitute the 3.925. And RA they given armature resistance of 3.39 ohms. Actually, we calculated in the first question. Armature resistance we calculated in the first question. So 3.39 ohms. Now we have to find out IA. Generally, the torque directly proportional to IA. So T2 by T1 is equals to IA2 by IA1. I want IA2. IA2 is equals to IA1 into, what is IA1? 3.925 into T2. What is T2? 2.5 by 5. If you calculated this IA2, its value 1.962. This IA value 1.962. Now this substitute here IA. So 186.67 is equals to V minus 1.962 into 3.39 ohms. Right? Then we can get the voltage V. V, if you calculated this voltage V, its value 193.3 volts. The required voltage we have to apply is 193.3 volts for this question. Here we have to find out IA from the torque equation. Then after substitute here, then we can get the voltage. A very simple question. But here this IA is very important to calculate. This is the next question. Very simple question. A very simple question. See here. A 4-point starter used to start and control the speed of A. Here two questions are there. Used to start and control the speed of A. A 4-point starter used to start and control the speed of A. Generally, see here, 4-point starter used to start the DC shunt motor as well as compound motor. Simply constant flux motors. To start the constant flux motors, we are using 4-point starter. Nothing but DC shunt motors and compound motors. So generally, shunt motor is there, compound motor is there. This is not correct answer. Either the three. Now, and control the speed of A. Generally, what is the disadvantage of 3-point starter? The disadvantage of 3-point starter is that we can't control the speed by using field weakening method. By using flux control method. We can't control the speed by using 3-point starter. But the advantage of 4-point starter is that the difficulty in 3-point starter is overcome. That's why now here see, this is wrong answer. Of course this is correct answer, but they asked the speed control. So tell me, which of the following is correct answer? DC shunt motor with armature resistance control or DC shunt motor with field weakening? In 3-point starter, this is not possible. That's why we are using 4-point starter. In 3-point starter, this is not preferable. This is not possible. That's why we are using 4-point starter to start the DC shunt motor with the field control method. Field control, speed control method. This is the preferable 100% correct answer. Right? Let's see here. A 220 volts DC shunt motor is operating at speed of 1440 RPM. Armature resistance and armature current they given. Excitation of the machine is reduced by 10%. Flux reduced by 10%. Extra resistance to be put in the armature circuit. To maintain the same speed and same torque. The speed should be same, torque should be same. Speed should be same, torque should be same, but the flux reduced by 10%. Here, we have to insert some resistance in the armature circuit to maintain the same speed and same torque. Right? This is our question. Let's see here. Initially, my supply voltage is 220 volts. And my armature resistance is 1 ohm. And my armature current is 10 amperes. And speed, of course, speed is same. No need to take the speed. And now we have to find out EB. Tell me, sir, EB is equals to V minus IARA. V minus IA into RA. EB nothing but 210 volts here. Here my EB 210 volts. Here EB 210 volts. Here the speed is constant, but flux is reduced by 10%. Nothing but phi2 is equals to 0.9 times of phi1. Phi2 is equals to 0.9 times of phi1 because 10% reduced. Then what is the formula? EB2 by EB1 is equals to N2 by N1. Both are same. And phi1 by phi2. Yes or no? What is the formula? EB directly proportional to phi into N, right? EB directly proportional to phi into N. EB2 by EB1 is equals to phi2 by phi1 into N2 by N1. N2 and N1 both are same. That's why those two gets cancelled out. So EB directly proportional to flux. Because the speed is constant. So EB2 by EB1 is equals to phi2 by phi1. Then find out EB2. EB2 is equals to 210 into phi2. 0.9 times of phi1 by phi1. Phi1 cancelled out. Then what is EB2 value? 21 into 9. Nothing but 189 volts EB2. My EB2 is there. Yeah, my EB2, I got it. Now, I want to find extra resistance included in armature circuit. Then see here how we are calculated. EB2 is equals to V minus IA into EB2 is equals to V minus IA into RA plus extra resistance. What is EB2 value? 189 minus what is V value? V value 220 minus IA into RA plus RE. Let's find out IA. And here IA into RA they given 1 plus RE. Now we have to find out IA. Here the torque is same. Torque should be same. Find out IA. But flux reduced by 10%. And then we have to find out IA. For that, we have to calculate IA. T1 is equals to T2. The torques are same. T1 nothing but phi1 IA1 is equals to phi2 IA2. Phi1 is phi1 only and IA1 is the 10 ohms. Phi2 is 0.9 times of phi1 and IA2 we have to find out. Phi1 cancelled out. Then tell me what is IA2 value. IA2 is equals to 10 by 0.9. 10 by 0.9 value 11.11 amperes. Here IA2 value 11.11 amperes. Because torque is same, phi1 IA1 is equals to phi2 IA2. Then we have to find out IA. Now substitute this IA here. Substitute this IA here. Then we can get back EMF. Back EMF is there, voltage is there. We have to IA substitute here. Then we can get extra resistance RE here. Right? Substitute here. For example, I am substituting here. For example, 189 is equals to 220 minus 11.11 into 1 plus RE. Right? If you calculate RE from this equation, if you calculate RE, just come here, and when it goes like that, its value you can get 1.79 ohms. You can get the extra resistance required to add here, the 1.79 ohms. 1.79 ohms. Okay, what we done? Actually, we calculated first back EMF. Thereafter, here speed constant, EB directly proportional to phi into N, speed constant, so EB directly proportional to phi, but they given phi2 reduced by 10%. From that, I calculated EB2. EB2 is equal to V minus IA into RA plus RE, extra resistance added. RA we know, but IA we don't know. This is IA2 actually, this is IA2. Then we have to find out IA2. The given torque is constant. Phi1 IA1 is equals to phi2 IA2. Then we can get the IA2. When we substitute this IA2, then we can get extra resistance. You have to add 1.79 ohms. This is your answer. See here, at 220 volts, 15 kilowatts, 1000 RPM, DC shunt motor, 1000 RPM, DC shunt motor, has armature resistance of 0.25 ohms and rated line current also they given 68 amperes. What they given? Supply voltage they given 220 volts and initially the speed given, the speed 1000 RPM and armature resistance they given 0.25 ohms. 0.25 ohms and line current they given 68 amperes. 68 amperes. Initially line current also they given, and next field current also they given. Field current 1 2.2 amperes. Line current 1, field current 1, and N1 they given data. Next, see here the change in field flux. The change in field flux required to obtain speed of 1600 RPM. Nothing but this is the second data. The speed is 1600 RPM. 1600 RPM. While drawing the line current off, and line current also they given 52.8 amperes. 52.8 amperes. And field current also they given. Field current also they given 1.8 amperes. 1.8 amperes. Now, what is the question? The change in field flux. The change in field flux we required to find. Right, tell me what is the relation to find out this one? The basic relation we have that the back EMF is directly proportional to phi into N. the back EMF is directly proportional to phi into N, nothing but the back EMF is directly proportional to field current and the speed. The flux, nothing but the field current. Now tell me what is the answer. EB2 by EB1 is equals to 5 N2 by phi 1 N1. I'm doing here. EB2 by EB1 is equals to, EB2 by EB1 is equals to phi 2 by phi 1 into N2 by N1. Phi 2 by phi 1 into N2 by N1. First we have to find out EB2 and EB1. Tell me what is EB2 value. EB2 is equals to V minus IA into RA. IA into RA. This is our EB2. What is IA? We don't know IA. We have to calculate the IA. How we can calculate the IA? IA2, right? I want IA2. How we can find out? Here, the line current they given and field current also they given. This is a DC shunt motor, right? This is a DC shunt motor. In shunt motor, what is the relation between line current, field current and armature current? In shunt motor, armature current is equals to line current minus field current. In shunt motor, armature current is equals to line current minus field current. So tell me what is the armature current? 52.8 minus 1.8. So its value 51. Then you can get the EB2 value. Now find out EB1. The same. EB1 is equals to 220 minus IA into RA. IA into RA. Now again we have to calculate IA1. For IA1, let's see here. This is my line current 68 and my field current 2.2 amperes. Then tell me IA, the armature current is equals to line current minus field current. Line current minus field current. Nothing but 68 minus 2.2. 68 minus 2.2. Nothing but its value 68 minus 2.2, right? Its value 67.8. 65.8. 65.8. 65.8. IA1. Then I substitute here. I get EB1 and EB2 values. Now we have to substitute here EB1 and EB2 values. And we have to substitute here N1 and N2 values. N1 and N2 values. Let's check it once. EB2 by EB1, nothing but these values. And EB2 by EB1, we have to calculate these two values and substitute here. What is EB2? 220 minus 51 into 0.25 divided by 220 minus 65.8 into 0.25 is equals to phi 2 by phi 1 into N2. N2 they given 1600. N1 they given 1000. 1600 by 1000. 1600 by 1000. Right? Now we have to find out phi 2 by phi 1 value, right? Now we have to find out phi 2 by phi 1 value, right? Let's see here. Now, if you calculate, if you solve this equation like this, these two gets cancelled. Its value 1000, right? Right. These two gets cancelled. 16 by 10. And if you calculate here, then finally you can get phi 2 by phi 1. If you calculate this, you can get phi 2 by phi 1 is equals to 1 by 1.57. Phi 2 by phi 1 is equals to 1 by 1.57. Nothing but phi 2 is equals to how much it is? 1 by 1.57. If you calculate 1 by 1.57, its value 0.6363. 1 by 1.57 value 0.6363 into phi 1. What is the value? The phi 2. The flux phi 2 is equals to 0.6363 into phi 1. Right? Just remember this. Now see the option. Just remember this. Now see the option. Now see the options. See the options. What we get actually? Phi 2 is equals to 0.6363 into phi 1. Nothing but here just 63% is there. Here just 63% is there. Nothing but how much percent reduces? 63.66, nothing but mostly 36.36% reduces, right? How much is less than 1? Simply 1 minus 0.6363. Then you can get 0.3636. Yes or no? 1 minus this value 0.6363, nothing but 0.3636. Nothing but this 0.3636% less than phi 1, right? So tell me which of the following is correct answer? These two are the wrong answers, 100%. Now tell me, is this is increased by 36% or reduced by 36%? Yeah, the phi 2 is less than phi 1 only. How much percent less than? 36.36% less than. Because the phi 2 value just 0.63 times of phi 1. This is not even 1. 0.63 times of phi 1. Nothing but 63% of phi 1. 63% of phi 1, nothing but how much percent less than phi 1? 36.36% less than phi 1. So our answer is 36.36% less than phi 1. So what they asked? The change in field flux. The change in field flux is 36.36% reduces. Right? This is the question. And here the basic formula is that EB2 by EB1 is equals to phi 2 by phi 1 into N2 by N1. We have to calculate EB2 and EB1. We know the values of N2 and N1. Then we have to calculate phi 2. If you calculate phi 2, we can get phi 2 is equals to 0.6363 times of phi 1. So the flux reduced by 36.36%. Right? At 250 volts, what is the supply voltage? 250 volts. This is shunt machine. Armature resistance of 0.6 ohms. And field resistance of 125 ohms. The machine is connected to 250 volt supply. The motor is operated as a generator and the motor separately. Actually, this is the machine. The machine is operated as generator and then motor separately. The machine is operated as generator and motor separately. The line current in both the cases 50 amperes. The line current in both the cases 50 amperes. The line current in both the cases 50 amperes. The ratio of speed as a generator to speed as a motor. The ratio of speed as a generator to speed as a motor is equals to how much? This is the question. First, this is generally the formula N2 by N1 is equals to EB2 by EB1 into phi 2 by phi 1. This is generally the formula you have to know. But here, the DC shunt machine, that's why the flux is constant. The flux is constant, this value constant. Then, what is the formula? The speed in generator to the speed in motor is equals to generator nothing but generated EMF, motor nothing but back EMF. Tell me the answer. Easy. Generated EMF is equals to V plus IARA divided by V minus IARA. V plus IRA divided by V minus IRA. Nothing but here we have to substitute generated current. Here we have to substitute motor current. Can you tell me what is motor current? Tell me what is motor current? IM is equals to, in motor, armature current is equals to line current minus field current. What is line current? They given 50. Can you tell me what is field current? Yeah, the field current IF is equals to V by RF. V by RF. V by RF, nothing but 2 amperes. So substitute here 2 amperes. Then the armature current in motor is 45 amperes. So tell me what is the answer here? V is the 250 plus IA. What is IA? 48 into RA. What is RA? 0.6 divided by V minus IRA. 250 minus. Let's see here. This is motor current, right? 48. So this is not generator current. Motor current is the 48 into 0.6. Now tell me what is generator current. In generator, armature current is equals to line current plus field current. What is line current? They given 50. The field current 2. Nothing but in generator, armature current is 52 amperes. In generator, armature current is 52 amperes. Nothing but in generator 52 amperes, in motor 48 amperes. Yeah. Now tell me the speed in generator to the speed in motor is equals to 250 plus 52 into 0.6. Can you tell me what is this value? This value 221.2. 281.2. This value 281.2. And can you tell me this value? 221.2. If you calculate this value, 250 plus 52 into 0.6 value, 281.2. And 250 minus 48 into 0.6 value, 221.2. If you cancel this one, you can get 1.271. If you calculate this one, you can get 1.271. So finally, the speed of generator to the speed of motor is equals to 1.271 is the answer. What they asked? The ratio of speed as a generator to the speed as a motor. The ratio of speed as a generator to the speed as a motor is equals to EZ by EB. EZ is equals to V plus IAZ into RA by V minus IAM into RA. What is its value? 250 plus the armature current in generator and armature current in motor substituted here. Then we can get 281.2 by 221.2. If you calculate this one, you can get 1.271. Nothing but the ratio is 1.271. This formula is very important here. And here flux is constant in DC shunt machine. That's why this is our formula. That's why the answer is this one. 1.271 is our answer. Okay, sir. Next question. See here. A 15 kilowatts 230 volts shunt motor. Shunt motor, the supply voltage is 230 volts. Shunt motor has armature resistance of 0.4 ohms and a field resistance of 230 ohms. Can you tell me what is field current? The field current is equals to V by RF. V by RF, nothing but 1 ampere. This is my field current. At no load, rated voltage, the speed of the motor 1400 RPM. At no load, what they given? At no load, the speed is 1400 RPM and the line current is 5 amperes. Can you tell me what is armature current at no load? The armature current at no load is equals to line current minus field current, nothing but 4 amperes. This is my armature current. Yeah. Next one, at full load. Next one, at full load. At full load, the given line current is 70 amperes. Can you tell me what is armature current at full load? At full load, my armature current is line current minus field current, 69 amperes. Neglect armature reaction, the full load speed of the motor. Now I want the speed of the motor. Actually, what is the formula for this? For this question, what is the formula we have to use? Generally, the speed N2 by N1 is equals to EB2 by EB1, because here flux is constant in shunt motor. Now, the speed at full load by speed at no load is equals to EB at full load by EB at no load. This is the answer. Tell me, EB at full load. What is EB at full load? At full load, V minus IA into RA. RA they given 0.4. And next one, V minus IA into RA. This is the EB naught. Then tell me the speed at full load by 1400, that is equals to 230 minus this value. How much you get? You get 220 or 202.2. If you calculate this value, you can get 228.44. What is the value? 4 into 0.4? 1.6. Yes or no? 1.6 nothing but 228.4. You can get 228.4 its value. Yes or no? 4 4s are 1.6, right? My armature current is 4 amperes, IA into RA. If you calculate the speed 1400 into 202.2 divided by 228.4, then you can get 1240.63 RPM. If you calculate this value, you can get 1240.63 RPM. The speed at full load is equals to 1241 RPM is correct answer. Because 0.63 not possible, right? That's why 1241 RPM is the correct answer for this question. Here my answer is 1241 RPM or 1240.63 RPM. Right? This is our question. See here, the no load speed of A 230 volts. The no load speed of A 230 volts. Separately excited DC motor is no load speed of A 230 volts. Separately excited DC motor is 1400 RPM they given. The armature resistance drop and brush drops are neglected. Armature resistance drop and brush drops are neglected. Generally EB is equals to V minus IARA plus brush drop, of course. The armature resistance drop also neglected. Then what is EB? EB is equals to 230 volts. EB is equals to 230 volts. They given that. Next one, the field current is kept constant at rated value. Field current also constant, there is no changes. Right? The torque of the motor in Newton meters for an armature current of 8 amperes is. What is that? The torque, they are asking the torque at 8 amperes of armature current. Nothing but they given armature current of 8 amperes. Now they want torque. Find out. What is the formula? Generally we know that P is equals to omega into T. P is equals to EB into IA is equals to 2 pi n by 60 into T. Right? Substitute EB is the 230 and IA is 8 is equals to 2 pi by 60 into 1400 into T, torque T. Then if you calculate this value, if 2 ones are 2 threes are, and like that, if you calculate all these values, then the torque T is equals to 12.55 Newton meters. The torque T is equals to 12.55 Newton meters you can get. So what is our answer here? The torque of the motor is 12.55 Newton meters. This is exactly correct answer. What I done here? Generally, we have to know that EB is equals to V. Because the resistance drop and brush drops are neglected, that's why EB is equals to V. There is no voltage drop actually. So the back EMF is equals to supply voltage, and then the power P is equals to omega into T, EB into IA is equals to omega into T, and we have to find out T is the value 12.55 Newton meters. Okay. Let's see here, sir. Separately excited 300 volts DC shunt motor. Separately excited 300 volts DC shunt motor. Nothing but V is equals to 300 volts. Under no load condition runs at 900 RPM. No load condition runs at 900 RPM. And no load condition armature current is 2 amperes. Armature current also they given. And armature resistance they given 0.5 ohms. And leakage inductance they given 0.05 henries. Loaded condition armature current also given. Under loaded condition armature current 15 amperes. And speed at loaded condition. This is my question. I already told you the formula same. What is that? The speed at normal condition, loaded condition by no load condition is equals to what is here? EB divided by EB at no load condition. Can you tell me what is EB? EB is equals to V minus IA into RA. V minus IA into RA. 300 minus 7.5. 300 minus 7.5, 292.5 volts. This is EB. Right? What is EB naught? EB naught is equals to 300 minus IARA. 2 into 0.5. So, 299 volts. Now tell me what is answer? N divided by what is speed under no load condition? 900 is equals to EB 292.5 divided by 299. If you calculate here this value 900 into 292.5 divided by 299 is equals to how much it is? It is around 880.63 RPM. 880.63 RPM. This is the finally our answer. The load condition. At this condition, the speed is 880.63 RPM. Right?